Okay, just a quick overview of the problem. It's a diaphantine. It's not linear, but it's something you could probably look at by inspection, come up with a solution to the problem. And that's what I want to go through over here, what I did initially. That I saw initially, I saw a solution. And again, I knew it was integer, and certainly positive integer. I'm looking at this over here. When I say certainly positive integer, obviously, I'm going to say as simple as case would be a positive integer. You get, excuse me, 3 and 4. And that does work out. And what I mean by that, I kind of looked at it and I said, well, 3 to the 4th power minus 4 to the 3rd power. Well, what is that? Let's write that down. 3 to the 4th is 3 times 3 is 9, 27, 81. 4 cubed is 4 times 4 is 16. 16 times 4 is 64. And that's going to give you 17. All right, so that does work out. So one ordered pair is 3, 4. Now, by the way, it took some time, but I eventually saw this one too. And what's this one going to be? It says 18, 1. Let's write that one down. 18 to the 1st power minus, that's going to be 1 to the 18th power. What do you get there? 18 minus 1, which is 17. That's another solution to the problem. Now, my suspicion over here is that there's probably some algebraic way of doing it, but I got to be honest with you, looking at it, I would say for the most part, if you got those two answers, that's great, all right? Now, these are unlike linear Diophantine equations, and linear Diophantine equations, like something like this over here, 2x plus 3y, so really, I'll give you a simple one over here. If you can find one solution to this problem, and by the way, one solution is really obvious is 1, 1, you can find an infinite number of integer solutions to the problem over here. But you see, I found 2. I don't know if there's others, though. I don't. So I want to tell you what I did. I did a graph. And someone said, what graph did you do? Well, I'm using Grapher. And I want to point out what I did was I did x to the y minus y to the x is equal to 17. And I just typed it in, and I got a pretty interesting graph over here. And then I was kind of looking at the graph, and I was kind of wondering, are there other integer solutions over here? Now, granted, I do plot out 2 of the solutions over here. This solution over here is 3, 4. What does that mean? X is 3, y is 4. And there's a solution over here, and that solution is going to be 18, 1. We've already verified that's true, by the way. But then I kind of start to look at this over here, and I wonder, are there other integer solutions? And, you know, one way to do it, and again, I'm not saying it's a good way of doing it, but you could look at the picture. Whoops, sorry about that. Got to go back. Get my ruler out again. You could look at the picture and start looking at integers. For example, look at 2. I certainly know 2 is not leading up to an integer over there. And then 1, I don't even see it. All right, and you say you have to trace all the way up there. All right, trace all the way up there to get that one. And you could keep looking around and kind of moving this thing around. 6. I'm looking at that. I don't, whoops. Give me 1 second. Looking around, again, you're going to struggle with this over here. My claim over here, I'm not really sure if there's more integer solutions over here. Right? I'm not sure. Now, again, the graph, it's not the easiest looking graph to look at, but the bottom line is, it is nice to have a graph. You can kind of look at this thing over here. I clearly got 2 solutions to the problem over here. However, I want to point out, I do want to go to the whiteboard. And going to the whiteboard, I want to go through the algebra. And the algebra is also somewhat misleading, by the way, when you do it, because you're making assumptions as you're doing the algebra. But I will go to the whiteboard. Let me see if I can find the whiteboard. Yeah, it's right over here. And let me expand that out. And let me just see if I have the right pen going. I do. And what I want to do is I want to write down what the equation looks like to me. It looks like a to the b minus b to the a is equal to 17. And again, my initial thing was I know that a and b are integer numbers. But if there's not integer numbers, you could basically pick any a you want and then try to figure out what the b is or vice versa. But the bottom line, they're integers. So what I did was I kind of looked at 17 and said, well, 17 is a product of 2 numbers, 1 times 17. Then I started thinking, well, maybe I could factor this thing. All right, I'll put this over here. I'll write this as b over 2 quantity squared, because I'm going to try to get a difference of perfect cubes by perfect squares, I'm sorry. Then when you get up here, you get a, I'm sorry, not a. I get b, a over 2 squared is equal to 17. And then what do? I try to factor it, and it's going to give me a difference of perfect squares. So get a, b over 2 minus b, a over 2 times a to the b over 2 plus b over a over 2. And that equals 17. And I start to realize 17 is a prime number. It's simply 1 times 17. And again, I'm making assumptions here, all right? One of the assumptions, these are nice integers, by the way. So over here, what do? I say, oh, a, b over 2 minus b, a over 2 is the number 1, right? And then I say the a, b over 2 plus b, a over 2 is equal to 17. Now granted, I'm in another conundrum, by the way. I got almost a very similar type problem over here, but the exponents get more difficult. But what I notice about these two equations over here, you can add them together. And if I add this equation here to this equation here, I get 2a b over 2 equals 18. Divide through by 2, and you get this over here. Now granted, my claim over here, this one's easier. Now what I mean by easier, looking at this up here and looking at this down here, I'm going to claim this one's easier over here. And someone says, what would that give you? Well, looking at it, right? You're trying to figure out what this is over here. And I'm going to say it looks like, let's take a be careful look about this, okay? I'm going to say A is 3. That's an integer, by the way. And the B is 4. I'm going to look at it and see if I can write that down. 3, and if B is 4, that would be 3 squared. And that does equal 9, by the way. So this is a solution that I'm going to say is an obvious solution at this point, all right? Now, so how do you get the other guy? And the other guy, if you looked at it, I'll write that one down for you. If I did this one and this one, instead of, subtracting them, instead of adding them, subtract them. And I'm going to say you're going to get 2b a over 2. By the way, I'm taking this, subtracting that. And that'll be 17 minus 1, which is 16. And then you get b a over 2 is equal to 8. Again, if you did that, you're still looking at this thing. And again, my claim, this is easier. What is it easier than? The original one, this one over here. This is tough. At least I believe it's tough. Looking at that over there, again, I'm looking at it, wonder what that would give me. And I'm going to say it looks like B is 4. And A let me see if I'm saying that right. If I did that right, 17 minus 1 is 16. I get 2. Yeah, A is going to be 3. A little more difficult, wasn't it? Let's write this down. 4. Right? I can put the A down now. That's 3 halves. Does that equal 8? Well, let's write this down. It's actually 4 times 4 to the 1/2. And that does work out nicely. It's 4 times 2, which does give me 8. Now, when I say this one's easier, I actually found this one to be the easiest one over here. But then someone says, you found another solution that would not satisfy this equation over here. It wouldn't satisfy it, all right? Now, what did I find? I found the solution 18.1, but 18.1 is not going to satisfy these guys over here. Yeah, if you plug it in over here, what would you get? You get 18 to the half power. That doesn't equal 9, all right? Now, you might look over here and say, well, let me try it over here. And what's that going to be? 1 to the 18 over 2, and that doesn't equal 8. So I want to point out some assumptions are being made. And I want to tell you what those assumptions are. I'm assuming that these things are integers, all right? They may not be integers. And that's where that other solution comes in, by the way. And what I mean by that, the other solution is 18, 1. Let me go back over here and plug this in. And again, I'm not making such integers now. I'm going to write this down. What do you get over there? The root of 18. Again, A is 18, the B is 1, the square root. Then when you have your minus, well, the B is 1. 1 to any power is going to be 1. And what do you have over here? Root 18 plus 1. And what do you get over here? You multiply this together, you get 18 minus 1, and that does equal 17. What are these things over here? They're not integers. What's my assumption over here? That these things were integers, all right? I can't make that assumption, by the way. This would make the problem so difficult for me. All right, let me go back to the problem over here, and I want to point out that I'm not saying I got the solution to the problem in its entirety. So I'm going to say, hopefully some bright minds will eventually chime in with a better answer, by the way. And what I mean by that, I'm saying these are the two answers, by the way. And I wonder, are there other ones, all right? Are there other answers to that? And that's really the pressing matter over here. This is a Diophantine, and I'm not very good at Diophantine equations over here. But the bottom line is, are there other ones? And you know what? Maybe someone says, oh, I found another one, and they list it, and they put it out. And I'll certainly give you credit and post your name down in the document. Thank you.